Welcome to Lionheart Academy. Today we're continuing our trigonometry lessons. We are on the vectors, on the topic of vectors. We have talked about some basic information about what is a vector. Magnitude is a quantity with magnitude and direction. We have talked about in the previous videos what to do with vectors, how to add, how to multiply vectors by a scalar, how to add vectors, and how to find the directional angles. So today we're going to put those things to use. We're going to look at some application problems. Most of the application problems will involve force and velocity because they are very easy to understand, and they're concepts that definitely involves magnitude and direction. Okay, now an airplane is traveling at a fixed altitude with a natural wind velocity. So in the beginning there's no wind, we assume, and then the airplane is heading north 30 west. Okay, 30 degrees west. Now we have to go ahead and stop for a minute and then talk about what does this mean in a moment. Okay, at a speed of 500 miles per hour. At a certain point it encounters a wind with a velocity of 70 miles per hour in the direction of north 45 degrees east. What are the resultant speed and direction of the airplane? Okay, now if you know about navigation, okay, then you might be able to figure out what our directional means. So let's go ahead and construct a diagram to represent the situation here. Now when we consider direction, okay, positive x-axis is east. North is always up there in the positive y-axis, and this is west to your left, and south is down. North is up, south is down, east is to your right, west is to your left. That's the basic understanding of operation. Now in aircraft navigation, they do use north 30 degree west and things like this, but they also use the headings. Okay, the headings for north would be 0. Okay, and the heading for east will be 90, the heading for south will be 180, the heading for west will be 270, or you can use 360 for the heading for north. But right now we are not using headings. Most likely if you have learned how to fly airplanes, you will know about headings. But north 30 degrees west would be this. So the initial velocity of our airplane, now let's assume our airplane starts from the middle, okay, from the origin. So it's going to go north, but it goes 30 degrees west. Okay, so this would be my initial velocity for the airplane. So that means this angle right here is 30 degrees. So this means going north 30 degrees towards west. So this is my original airplane. My airplane is flying in this direction, okay, at 500 miles per hour. So the velocity, the initial velocity is like this. Then at a certain point there was a wind of 70 miles per hour in the direction of north 45 degree east. Okay, so that means we have a wind velocity, I'm going to use green here, encountering at 45 degrees, right, north 45 degrees east. So if I go to north, I go to 45 degrees, kind of like a halfway, 45 degree west, east, I'm sorry. So it points towards to the northeast direction, okay, northeast direction, and this is 45 degree west. So basically, this is the green, the blue one is the velocity of the airplane. The green one is the velocity of the wind. Okay, I'm going to use W, and we want to find out what is the resultant vector of the airplane. Okay, resultant speed and the magnitude of the airplane once the wind kicks in, and the ones that we take into consideration. So basically the airplane will be blown off course, okay, if it keeps the same heading, and that's why it's very important to always constantly adjust. The airplane pilots, they have to adjust for headings when they deal with their course, and then they have all the pilots computers on board, allowing them to do calculations very quickly based on all the informations they have received. But so it's one of the examples of how you need to know math, how you have to have a concept of math to become a pilot, and to become not just a pilot but navigations in on the ground or in the ocean and things like this is very useful to learn trigonometry. This is one way. This is one of the things that navigators in the past, they are very good with math. They need to know how to calculate. And use all kind of trigonometry and geometry and other things to help them determine what they need to know. All right. So let's go ahead. So right now we have our situation here. So we want to find out our resultant vector. So let me go ahead and use a different color here. Let me use black. The resultant vector would be something like this. That would be the resultant vector. Okay, that would be the resultant vector. All right. But how do we go ahead and do this? Now I've got to mention that we have to label a little bit here from here. Okay, just a little bit. And we want to know, we know that this angle, okay, the angle for the angle W, that little angle is 45 degrees. Okay, so let me go ahead and write it out here. It's 45 degrees. Yeah, because it's north 45 degree east, so on the other side is also 45 degrees. Right? So it's 45 degrees. Okay. Alright, so this angle is 45 degrees, this angle is 30 degrees. So how should we go ahead and do this? Now we can go ahead and break them up into components and add the components together. Okay, if we break them down into components, add the components together, we will be alright. But so right now we know vector v, right? The airplane's the magnitude of v is 500 miles per hour. Okay, miles per hour. And the directional angle for v is 30 degrees. Alright, and we know the wind, the magnitude of the wind is 70 miles per hour. And the directional angle of the wind is 45 degrees. Now actually I made a mistake, I'm sorry. The directional angle for the velocity, for the wind speed of the airplane is not 30 degrees. It's actually 90 degrees plus 30 degrees, because when we're talking about angles, it's actually 120 degrees. The reason is we have to start from the initial side. So this part is 30 degrees, and as you can see, this part is 90, of course. 90 plus 30 is 120. So it's 120, so that will put us in the right quadrant. And W is 45 degrees, that's alright, because it's north 45 degrees east. So it's in first quadrant, and then both sides on the W, if you go ahead and draw a quadrant here, this is 45, that is also 45. So okay, so now we know our two vectors in polar form. We know their magnitude, we know their directional angle. So how do we combine them? How do we add them? Now in order to add vectors, we have to remember that we need to go back to component forms. So we need to find Vx, okay, and we need to find Vy. Alright, the component for x and y. Now the component for x and y is very simple. In order to break down to the component for x, we use the angle, we use cosine of the angle, because remember cosine x is always the x component, right? So this will be 500 cosine of 120 degrees, and the y component will always be sine of the angle 120 degrees, right? Because the vertical components is the opposite side of the angle. So that's why we know Vx is 500 cosine 500, because 500 is the magnitude of the vector, which is equivalent to the hypotenuse. So cosine of the angle here would be the x over r, right? So therefore x would be equal to r times cosine of theta. R times cosine of theta, which we did before. I believe I have shown you that before, but let me go ahead and draw another diagram to show you that before we go on. Okay, so let me go ahead and erase this very quickly. Okay, let me go ahead and show you how that looks like, just in case I did not show you clearly. So I'm going to draw V. I'm going to draw V separately just for a moment here. So V looks like this. Okay, north 30 degrees west. This is my V. Okay, this is 30 degrees, and so altogether this is 120 degrees. All right, so we know the magnitude is 500. So we can actually break it down into two components, the y component and the x component. The x component. Okay, so the y component here and the x component here. And as you can see, if I extend this line down here and extend the line down here, how do we get the y component? How do we get the x component? Okay, this is also on here, right? The red line is actually also, the red vector is also equivalent to here, so I can put the y component. This is the vy, and this is vx. So the vx is down the horizontal line, which is equivalent to your cosine, right? Cosine of vx is equal to, so I can say, let me go ahead and write it down here. So the blue one is the magnitude of v. So if we take cosine of theta of v, right, theta of v, we should get the adjacent, which is vx, divided by the magnitude of v. And if we take sine of theta of v, we should get vy, with the magnitude of vy, our vy vector, divided by the magnitude of the v vector. So based on this information, we can say yes, okay, so that means if we want to solve for vx, because we know the cosine of the angle and we know the magnitude, so the component, the x component, will simply be the magnitude of the vector times cosine of the angle of the vector. And vy would be the magnitude of the vector times sine of the angle of the vector. Okay, so this is a very basic triangle thing. We're just using the angle theta here to help us figure out, and then the r, the radius, to help us figure out the x and y component. Alright, so let's come back to the problem here. So vx would be equal to 500 times cosine of 120 degrees. Okay, so cosine of 120 degrees is cosine of 120 degrees is negative 1/2, so this would be negative 250 miles per hour. Vy would be 500 times sine of 120 degrees. Now sine of 120 degrees is square root of 3 over 2, so this becomes 250 times square root of 3. Okay, sorry, let me go and write it a little bit better. 250 square root of 3. Okay, 250 square root of 3. Alright, so that's what Vx and Vy is. Alright, now what about Wx? Wx is 70, which is the magnitude times cosine of 45 degrees. And so that would be 70 times square root 2 over 2. So it would be 35 square root 2. Alright, and Wy will also be equal to 70 times sine of 45 degrees. Now cosine and sine of 45 degrees are the same, so we would expect the same answer. It would be 35 square root 2 miles per hour as well. Alright, so those are the components for v and w. Alright, so when we want to do v plus w, then our components, we will have to add the components together. The x plus x component plus x components, and the y component plus the y component. Alright, so this would be an exact answer of what the components of the resultant vector would be, v plus w. Now, to determine the magnitude of the resultant vector, let's go ahead and substitute them into your calculator. We're going to do negative 250 plus 35 square root 2 square plus 250 square root 3 plus 35 square root 2 quantity square, and then square root the whole thing. Okay, so let's go ahead and type that in. Alright, after we type in the calculator, we got approximately 522.51 miles per hour. Okay, so the wind did speed up the airplane a little bit. Okay, the wind speed up the airplane a little bit because it's also blowing northeast. It's blowing northeast, so it's still the airplane is heading northwest. So there's a component of the wind that causes the airplane to speed up, which is actually the y component. As you can see, I'm trying to write this a little bit better here. I'm sorry. So 35 square root 2. So as you can see, the 35 square root 2 from the y component add on to this original speed of the airplane. Even though in the east and west direction, the airplane is slowing down a little bit, but there's a compensation here. Now, what about the directional angle? What about the direction? The direction of the final resultant vector. So let's do arctangent. Now, this is going to be arctangent of y over x. Okay. Now, the resultant vector shouldn't be changing to quadrant 1. The airplane shouldn't be blown all the way off course back to quadrant 1. Like it will go heading north to east instead of northwest. So we should expect that this angle to be in quadrant 2. Alright. So let's go ahead and plug in again and see what's the angle. Now, if it's in quadrant 2, we need to add 180 degrees. Okay. So let's remember that. Alright, so after that we get about 122.6 degrees, 56 degrees, okay? So that means it's still, it's off course by about 8 degrees. It was heading 120 degrees. Now it's off the course by about 8 degrees. So they do need to make adjustment based on that. But that is approximately the directional angle that they headed to. Now, paying attention, this is not the right heading numbers if you're an airplane pilot. Okay, this basically what means is about north. Let's go ahead and subtract 90. This is about north 22.56 degrees west. Okay, so as you can see, they were heading north 30 degrees west. Now they're heading north 22.56 degrees west because of the wind. Okay. Alright, so that's a long problem, but it's worth to pay the attention to details and things like that. Let's look at two other examples. Let's look at some forces examples. Alright, so there's an object, okay? There's an object, and there are two forces pulling on it. Now, let's go ahead and draw a diagram and then see if we can recreate the situation here. Now, one object has 2,000 pounds working on it, but has 30 degrees, so it's 30 degrees with respect to the x-axis. And one object is 900 pounds, but 45 degrees with negative 45 degrees with respect to the object. So let's say the object is at origin. Alright, we have two forces. Okay, this is force 1, this is force 2. So force 1 has a magnitude of 2,000. Alright, hold on. And this angle is 30 degrees with respect to the positive x-axis, and this angle is negative 45 with respect to the x-axis. Now we want to find out the resultant force. Okay, so we want to add force 1 plus force 2. Alright, but we do know force 1, the magnitude of force 1 is equal to 2,000 newtons. Alright, and the directional angle of F1 is equal to 30 degrees. Okay, there's no problem there. Now F2, force 2 is 900, the magnitude of force 2 is 900 newton. And the directional angle F2 would be equal to, now it's negative 45, so if I want to represent using positive angle, actually I can use negative 45, that's no problem, because it's in quadrant 4, so we really shouldn't have any problem breaking it down to using negative 45 degrees to break it down into components. Now if you want, you could use 315 degrees. That's a positive equivalent angle for that. Alright, so let's break down F1x. Let's find out what F1x is. So F1x would be the magnitude of F1, okay, times cosine of 30 degrees. Alright, cosine of theta of F1. Basically, that's what that is. So this would be 2,000 Newton times cosine of 30 degrees. Alright, now cosine of 30 degrees is the square root 3 over 2, so it will be 1,000 square root 3 Newton. And F1y would be the magnitude of F1 times sine of the angle F1. So it would be 2,000 Newton times sine of 30 degrees. Sine of 30 degrees is 1/2, so that will be 1,000 Newton. Okay. Alright. And F2x would be equal to the magnitude of F2, which is 900 times cosine of this angle, negative 45. So, but negative 45 cosine of negative 45 is the same as cosine of 45, because cosine is an even angle. Okay, so it's negative is equivalent. So this would be 450 times square root 2. Okay, times square root 2 over 2. And let me go and screw up a little bit. Oh, that's too much. Okay. And f2y would be the absolute value or the magnitude of f2 times sine of theta of f2. Alright, so it's 900 times sine of negative 45 degrees. Now, sine of negative 45 degrees is the opposite of sine of 45 degrees. It's a negative sine of 45 degrees. So this would be a negative 450 times square root 2, because it's 900 times square root 2 divided by 2. Okay? Alright, so now we're ready to add them up to find the resultant force. So F1 plus F2 would be equal to 1000 square root 3 plus 450 square root 2 for the x component. The y component will be a little bit less. The y component will be 1000 plus, or I should say minus 450 square root 2. Alright, so that's those are the resultant vectors in component form. Let's go and find out its angle and magnitude. So its magnitude, okay, is going to be the square root of this plus the square root of x squared plus y squared. Alright, so let's go ahead and write that square root of 1000 square root 3 plus 450 square root 2 quantity square plus 1000 minus 450 square root 2 quantity square. So altogether square root. So let's see. Okay, let's plug into a calculator. Alright, so it came out to be about 2396.2.19. Let's go ahead and round it up to 100. 0.19 Newton. Okay, so it's quite an increase of the. It's not quite an increase of the force. If you think about this, it's 2000 plus 900, because they're pulling in different directions. So altogether, the combined force is not that great. But what about the directional angle? Let's go ahead and use arctangent. Let's use arctangent of the y over x. Alright. Now, I do believe the resultant vector would be approximately in quadrant 1 or in quadrant 4. So we shouldn't need to do any other adjustment to this. Let's go ahead and just plug into the calculator then. Alright, so this came out to be about 8.73 degrees. 8.7 degrees. So it's slightly pulling over to the 2,000 pound, which is expected because the 2,000 pound force is a little bit more. So that's the resultant vector, and then the magnitude and the direction of this vector. Alright, let's go ahead and take a look at one last example. This is a very important example. An object weighs 500 pounds is resting on an incline that has an angle of elevation of 20 degrees from the horizontal ground. Find the force of friction necessary to keep the object from sliding down the ramp. Alright, now if you have learned physics before, you might have seen this problem, this kind of problem. So let's go ahead and draw an object. I'm going to draw an object on an incline. Now when the object's at rest, that means the sum of the forces acting on the object is equal to 0. Alright. Now, when the object is resting on the incline, now that we know the degree of the incline is 20 degrees. Okay, so this angle is 20 degrees. Now, we know an object has several forces acting on it. One of the force is gravity, right? The first force acting on it is gravity, and I'm sorry, I couldn't even draw that straight. The gravity force is pulling down on the object. Okay, so it's the force of the gravity. And there is a normal force. A normal force is the force that's perpendicular to the surface. It's perpendicular to the surface. It's going towards the top. Okay, it's going to the opposite direction of the gravity. So it's pushing it up, because the gravity is pushing the object. The weight of the object acting by the gravity is pulling down. So there's a normal force from the surface of the incline pushing it back up. It's one of Newton's laws of equal and opposite forces. Now there's another force at work here. It's called the force of friction. the force of friction does. That's what we want to find out. So the force of friction is keeping the gravity from pulling the object sliding down the slope. Okay, so we want to find out what would the force of friction be if this object is 500 pounds. Okay, 500 pounds is the measure of force, and the elevation is 20 degrees. Okay, so one thing first of all is I want to set my reference frame. Okay, I want my reference frame, my XY plane, to be in the direction of the incline rather than the horizontal. So I want my XY plane looks like this. Okay, a little bit hard to see, but I want my origin to be at object, the center of mass of my object to be at the origin, and I want my x-axis to go up like this and y-axis to go up like that. So the normal force is in line with the y, and the friction is in line with x, and so the gravity is not in line anymore with the x and y-axis. It's okay. So what we have to do is we want to break down the gravity. As you can see, the gravity can be broken down into two parts. So when we deal with force and when we deal with forces, we always break them down into components. So the gravity can be broken down into two components. As you can see from the center of gravity, you can break it down to the x component and the y component. Okay, so this is called the FGY, and this let's call FGX. All right. So now, as you can see, we have two forces. There are forces acting on this object in different directions. Now, if you look at the x directions, there are two forces. There's one friction force pulling up or pushing up, preventing the box from sliding down. There's a force of gravity pushing down. So, and then there are two forces acting in the y direction. Now, because the box is resting, is at rest, that means the box is not moving, it's not starting to accelerate. So all the sum of the forces should be equal to 0. Now we don't have to worry about the forces in the y direction, and now they should add up to 0. It makes sense, right? Otherwise the box will be either sinking into the pavement, sinking into the incline, or floating up above the incline, which is not going to happen. Also, the forces in the x direction along the incline should be also equal to 0. Otherwise it's either going to move up the incline or move down the incline, which shouldn't be. But of course, if the force of friction, if the box is too heavy and the force of gravity pulling in this direction, in the x direction here, is too strong and it overcomes the friction, then eventually it will start to slide. Okay, that's what would happen. So, but let's go ahead right now, because this box is resting, so we know that in the x direction, okay, in the x direction, the force of the friction is equal to or plus the force of the gravitational force in the x component should be equal to 0. That means they should be equal to each other. They should be equal to each other. Of course, they are equal and opposite. Okay, but the key right now, so because we want to find out what f of f is, so it should be the opposite of f of g of x. Okay, all right. So the key now is, what is f of g of x? What is the component here? What is this guy? Well, it is the component of f of g. So f of g x is the component of f of g, right? The x component of f of g. So basically, we need to now find out the magnitude f of g times cosine of the angle f of g. Okay, the gravity. Now we already know the magnitude. Why do we know the magnitude? Because the object weighs what? 500 pounds. So this is the magnitude. This is the magnitude of the gravity, or how much gravity is working on it. But we have to find out the angle. So it doesn't give us the angle, but it does tell us the incline. So this angle is 20 degrees. So we have to take a look at this diagram to figure this out. Now, if you look at this diagram here, the gravity forms a perpendicular line with the ground. This is the ground level. Okay, with the ground, now with the incline with the ground. So this is the right angle here, 90 degree. And then this angle right there should be 70 degrees, okay, because that angle and 20 degrees, they are complementary, okay, 70 degrees. And based on this 70 degrees, okay, hold on, this 70 degrees. Based on this 70 degree angle, this is the incline, right? That is the angle the gravity is making with the incline from this direction. And the x-axis is the incline. The incline is the parallel with the x-axis. So this angle right there is also 70 degrees, right there. They are the same because they are corresponding angles formed by two parallel lines and the transversal. Two parallel lines and transversal. So this is 70 degrees. So the gravity is actually the angle of the gravity is actually 180 plus 70, so which would be 250 degrees. All right. So this would be 500 pounds times cosine of 250 degrees. Again, how do I get 250? Is 70 plus 180. You see, if we're gonna keep our measures straight, we're gonna start from measuring the initial side. We're gonna start measuring from the initial side all the way down here is 250 degrees. Alright, so f of x would be 500 times cosine of 250. Let's go ahead and type in a calculator. Now that would be negative 171.01 pounds. Alright, so that is the magnitude. That is the magnitude of, or actually I should say the f of f, right? F of f. The magnitude f of s should be equal to the magnitude of this, which is 171.01 pound. So the force is necessary, the friction necessary to keep this object from sliding down would be 171.01 pounds. Okay. Alright, so if there's any other question, please leave your question in our comment sections. We hopefully to see you again in our next videos. We'll continue to talk about vectors, other topics of vectors. Thank you. See you next time.